Greetings again, everybody. This is Professor Nardi, the ex-phys guy, back here after a while to go over how to estimate VO2 max from a multi-stage sub-maximal test that does not have some kind of chart or graph to go along with it. Now, for this example, we are using the Bruce protocol treadmill test. I have all the math and everything written out already on the board, and my goal is to go over it step by step so that it is understandable to make sure that we can properly calculate this. Now, the base equation is up at the top where my little green pointer is up here. In order to estimate VO2 max, we will need this equation. VO2 max equals sub-maximal 2 plus A times the difference of the heart rate max and the second heart rate, which I will go over. Now, since we are using a multi-stage test, we will have multiple VO2s and multiple heart rates that will help us calculate this. If you focus on the blue, the writing that is in the blue, you will notice SM2, SM1. SM2 is the submaximal VO2 at the higher stage. SM1 is the submaximal VO2 at the stage just prior to SM2. And SM2 is always the highest stage that is completed. Now, heart rate 2 is the heart rate at SM2. Heart rate 1 is the heart rate at SM1. We need to know those before we can move on. We also will need data from the Bruce protocol, which is over here. Now, if we divert our attention back to this base equation, you'll notice this A. What A is a slope. It's a calculated slope from the heart rate that we will use to extrapolate a response to estimate the VO2. Now, I have put the equation for slope in here in the red. It's submaximal VO2 2 minus submaximal VO2 1 divided by heart rate 2 minus heart rate 1. And I've put the numbers up there already. And I've got those from these given numbers over here where the green dot is coming. I just threw some numbers in here. Stage 1 Bruce protocol. Here's heart rate 1. Heart rate 2, heart rate 3. This circled heart rate, which is 130 beats per minute, that is going to act as our HR1. This stage 2, where we have heart rate 140, 145, 152. This circled 152 will act as our heart rate 2. And I've also put the standard stage 1 and stage 2 speeds and grades of the Bruce protocol over here on the right. Now that we have all that given information, what we basically have to do is use ACSM metabolic equations to calculate the VO2 for stage 1 and the VO2 for stage 2. So if we come over here, we will see the equation 0.1 times speed in meters per minute plus 1.8 times speed in meters per minute times the incline, which in stage 1 is 10%, so that goes in as 0.1. Then plus the 3.5, that's our resting. The next, what I have written out here is this portion completed, this portion completed, and the 3.5. So this 1.8 times 45.56, that's the speed of stage 1 in meters per minute, and I have that written down here, each stage. When we finish, if you've watched the other videos on the channel, you'll know already how to do these. We have 16.25 milliliters per kg per minute. That's the VO2 at this workload. The VO2 at stage 2 is calculated here, which would be 24.672 milliliters per kilogram per minute. So we have 0.1 times speed in meters per minute plus 1.8 times speed in meters per minute times the incline plus the resting. And here's the math done out. So now we have our SM2 and SM1. We can plug SM2 into the slope equation up here, as well as SM1. We can also plug in our heart rate 2, which is the 152, and we can plug in our heart rate 1, which is 130. It's the highest heart rate at each stage. Now we can calculate A, which is our slope. I've done that down here. All right, it's make sure that we do 24.672 minus 16.25 first. Make sure that we subtract heart rate 1 from heart rate 2 first. Then we will divide this number here by this number here, and it should be roughly 8 divided by 22. It would be somewhere in that range, and we should get a slope of 0.38. We now have everything we need to calculate VO2 max. We can plug in our sub-maximal 2, which is 24.672, our slope, which is 0.38, and then we just have to quickly find heart rate max, age predicted heart rate max. I used an example of a 22-year-old individual. So it would be 220 minus their age, which would come out to be 200. Then we subtract the heart rate 2, which in this case is 152. So do this first. Get that number first. It should come out to 48 if my math is correct, just sort of off the top of my head there. So 48 times 0.38, that should give us 18.24. If we add that to this 24.672, that should give us 49, or sorry, I wrote this wrong, 42.91. So let me fix that. We all make mistakes. So now we have our correct estimated VO2 max. So one more time, when you're up here in the base equation, make sure that you multiply the slope by the differences of the heart rate first. Then you can add that number to the submaximal VO2, and that should give you 42.91. My apologies for having the incorrect VO2 max up there before. So I hope this wasn't too confusing with all the numbers already written out. But if you've watched the other ACSM metabolic equation videos, this should be very easy. The only extra step we are actually finding is finding the slope, which is A.